Hey, geometry students. We're here in lesson 10.1, and we have some new vocabulary. Our new vocabulary: circle, center, radius, chord, diameter, congruent circles, concentric circles, circumference, pi, inscribed, circumscribed. All right, special segments in a circle. We have radius, plural is radii. It's a segment with endpoints at the center and on the circle. So we have examples here. The examples of our CD, segment CD. So we can indicate that right here. This ends up being a radius. And so is CE. And so is CF. Those are all considered radii, with a center of C. Okay, then we have a chord. A chord is a segment with endpoints on the circle. So we do have examples here. We have a chord AB, because the endpoints are on the circle. And then we also have a chord DE. Now DE is a special chord. It's also called the diameter. Diameter of a circle is a chord that passes through the center and is made up of collinear radii. Okay, example number 1 here, we're going to identify segments in a circle. So here it says name the circle and identify a radius. Well, we can easily name the circle, right? We can name it by the center. So we have the center E. So we can say circle E, or the way we can do that is put this little circle with a dot in it and put an E next to it that represents circle E. And the two radii that are shown, looking for a radius, are going to be segment EB and segment ED. Starting from the center, right, and ending up the second endpoint being on the circle itself. Now it says identify a chord. Identify a chord. Well, we have a couple of different chords that we can name. Let's just name one of the chords. Remember, chord is where the endpoints of the segment are on the circle itself. So we have endpoints of our segment WZ. Okay? So we have 3 chords. We just named WZ. Okay? But there's also going to be the segment WY that's a chord, and XZ that's a chord, because those are also segments that have endpoints on the circle. However, WY and XZ segments pass through the center of the circle, therefore they're also called diameters. All right, name the circle and identify the radius. Go ahead and pause your video and answer the question. Good, it's circle F, and we have a radius identified as Fn. We also have a radius of Fa and a radius of Ft. Okay, check your progress. Which segment is not a chord? Go ahead and pause your video and answer the question. Okay, segment Fn is not a chord because one of the endpoints of that segment is not lying on the circle itself. It lies in the center. Okay, so we have a key concept in section 10-1. It's the radius and the diameter relationship. If a circle has radius r and diameter d, then the following relationships are true. Basically what it says is a radius is half a diameter. Okay? Another way of stating that is a diameter is equal to twice the radius. Okay, so in our problem here we have segment RT, which is also considered a diameter. So this is a diameter. and it wants to know what's the length of QV. Now, since QV is a radius, and we know that the radius is exactly half a diameter, then we have the fact that our diameter formula, and we know therefore the radius has to be exactly half, or 10.5. Okay, check your progress. In this problem, we're looking for QS equals 26 centimeters, and QS currently is a diameter. And we would like to know what's the length of RV, which is considered a radius. Go ahead and pause your video and answer the question. And you're right, the answer should be 13, exactly half the diameter. Okay, we have some more key concepts. Okay, we have two circles are congruent if and only if they have congruent radii. So we have segment GH, which is also a radius, is congruent to JK, which is a radius. Therefore, we have circle G is congruent to circle J. Okay, and then it says concentric circles. They are coplanar, so they live on the same plane, that have the same center. So they both have center A, but one of these circles has a radius of the segment length AB, and the other one has a segment length of AC. But they share the same center. Okay, find measures in intersecting circles. Okay, so we have a diameter of our circle X. So we know that the radius here from X to Z is a radius of circle X, and that length would have to be 11. Why 11? Because XZ is a radius, and they told us that the diameter was 22 units. Okay, the diameter of circle Y, okay, is 16 units. So we know the distance from Y to W, or line segment YW, is half of 16, which is 8. So we know this distance here has to be 8. Okay, so they also tell us that WZ is 5 units. So we know this length right here to here is 5. It wants us to find XY. Okay, so XY is the length from the two centers. Well, it looks like since WY is 8 and WZ, and Z falls between W and Y, that we should be able to establish that this length right here should be 3. And we should be able to do the same thing over here for the XW. Since we know XZ is 11 and WZ is 5, then XW should be 6. So if we want to know the length between X and Y, we have X to W, W to Z, and then Z to Y. So we have 14. Look back at our picture. That's how they solved it, showing all these fancy steps. Right? But we have 6 plus 5 plus 3, which is definitely 14. Check your progress. Okay, this one might be a little tricky one, so go ahead and take your time. Okay, go ahead and pause your video. And then see if you can find out the length of AC. And the answer is 7 inches. All right, another key concept in lesson 10-1 is called the circumference. A circumference, if a circle has diameter D or radius R, then the circumference c equals the diameter times pi, or twice the radius times pi. So we have a little formula for the circumference, or the distance around the circle. So if we're going to travel all the way around, that's called the circumference. And we can find it by multiplying 2 pi times the radius, or pi times the diameter. Pi is approximately equal to 3.14. Alright, so here's a real-world example. A series of crop circles has discovered in Alberta, Canada, September 4th, 1999. The largest of the 3 circles has a radius of 30 feet. Alright, so if we know that the radius is 30 feet, and we're trying to find the circumference, we know circumference simply is 2 pi multiplied by the radius. So this looks like it's going to be 60 pi. And pi is about 3.14. So this is going to be somewhere in around 180 feet. So since the radius is 30 feet and diameter equals 2 radius, then the diameter is 2 times 30, or 60. So therefore we have a circumference formula, and we use substitution and 60 pi. And like I said, somewhere about 180, we have an answer was 188.50 using a calculator. You should be able to find the pi symbol on your calculator. Alright, check your progress. Go ahead and pause your video. And the answer is 377 feet. Alright, we're going to find a diameter and a radius. So we're going to find the diameter of and the radius of a circle to the nearest hundredth if the circumference of the circle is 65.4 feet. So what we know is circumference, which is equal to 2 pi radius. Right? That's our formula we could start with. This is 65.4. We already know this number. And we're going to set this equal to 2 pi. And 2 pi is just a number, so like a little bit over 6. And then multiply by the radius. Well, I could divide both sides by the 2 pi. And that gives me my radius. So we can use a calculator to find this value. And then if we want to find the diameter, I'm simply going to double this number. So that when I double this number, I guess we can just say 65.4 divided by pi. Because if I multiply the top here by 2, let's say to double, then these 2's would cancel. So that's my diameter. So just use your calculator to find both. So there we go. Circumference equals pi d. 65.4 equals pi d. Divided each side by pi. So they solved it by solving for the diameter first, and then they're going to double it to find the radius. And then we're going to double it. Or, I'm sorry, take half of it to find the radius. That was my bad. Right, check your progress. Go ahead and pause your video and find the radius of a circle to the nearest hundredth if its circumference is 16.8 meters. Answer is about 2.67 meters. Okay, then we have a standardized test example here. We're trying to find the exact circumference of circle K. Now, what we probably need to notice here is that this side is going to be called a radius because it starts at the center and has an endpoint on the circle. But this height of the triangle also is a radius. And when we say it's a radius, remember the radius is the same. So what we're going to do is we're going to say, probably by Pythagorean theorem, that r squared plus r squared is going to equal the hypotenuse squared. And this is the hypotenuse. So when I square 3 radical 2, I get 9 times 2. So I have 2r squared is equal to 9 times 2. Divide both sides by 2, and I get r squared equals 9. Therefore, r must be 3. The radius must be 3. If the radius is 3, remember circumference is simply going to be 2 pi times the radius. So we're going to, in this case, our circumference is going to be 2 pi times 3. And it does say it wants to give us an exact answer, so we're just going to say that it's going to be 6 pi. You need to find the diameter of the circle and use it to calculate the circumference. Well, we're going to find we found the radius instead. All right. So the radius of the circle is 3. We can use 2 pi r or 6 pi. Therefore, our answer is 6 pi, just like we got.